Oh, I know that. I'm just trying to. So have y'all had a good weekend?
Yep.
Anybody do anything interesting, fun, different?
Went to the lake and forgot my shoes there.
Linear?
So, yeah, it's the lake around Lake Linear. I went with one of my friends, but we didn't go on the slides.
Oh, Linear Islands.
Well,
Yeah.
At least you can wear another pair of shoes until you get those back.
Yeah, this is what I'm wearing.
What kind of shoes were they? Were they sneakers or sandals or?
My black ones that I usually wear.
Of course, that's how it goes. Cole left his wallet at the gym on top of his locker on Friday and spent the weekend trying to figure out where the heck it was. And finally got to the point where he was like, I know it has to be at the gym. So last night when he went to practice, he was like, yep, there it was, sitting right on top of my locker. That makes me nuts when you lose stuff like that. Morning, Jocelyn.
Good morning.
Volume up. All right. You what? Oh, okay. Whoop. Who's dinging me over here? Oh, she needs, let me fix that real quick. Oh, I know. I'm sorry. I keep hitting the wrong button. Stupid computer. How about I do it this way? Oop, there goes the rain. That's fun. Just a little bit of rain.
Miss Danny.
Yes.
There's this anime character that like has these like Bluetooth headphones around their neck and like the same color of my hair and like this kind of hairstyle. It's a like boy character. And like one time my friend was like, "You look like Tsukishima," which is the name of the anime character, and I'm like,
Oh no.
Yes, I do.
That's funny. Is that a good thing or a bad thing? Is it an anime character you like? Okay, I was gonna say, if this is an anime character you don't like, that may not be a great thing. You're like, oh my god, no. I don't look like that one. E, I hope you didn't get wet. I'm sorry. It just started all of a sudden. Oh no.
Raining?
All right, there we are.
Did it start raining?
Good morning, Miss Jules. What's shaking, shake and bake?
Not wearing a regular suit.
Yeah, no suit today. She said, don't feel like it today.
It's sunny here. Very sunny.
Really tired.
I feel you on the really tired. This time change has been rough this go
Both
around.
of my
I don't know
shades
why, but it's
Then
been
this
way
is how
worse.
bright it would be.
Okay, it's been really bad, hasn't it? It's usually not this terrible, but it just is terrible this time. It makes me crazy. All right, let me make sure I have everything I need for today. All right, so I think we have everybody now. Sonia should be logging in just a second. So I'm gonna switch over to my screen for Jocelyn. Jocelyn's making herself beautiful, even more beautiful. There you go. All right. Did she get it? Yeah, she's got that. So we're good. Alrighty. Let's see about today's lesson. Can you see my screen there, Jocelyn?
Huh?
Yeah. Good
Yeah, I
deal.
can see it.
All right. So today you had a much shorter lesson this week, right? You just had notes, and that's because your book doesn't. Oh, is this Sonia? Does she have a problem? Can she get in? Sonia. Uh-oh. Can you show me like the numbers to get it? Okay. Hold on. Sonia needs some help. Let me make sure. One more second. She's stuck somewheres. No, not that link. This one. Okay, let me go this way. Just too many tabs.
They're also similar.
Too many tabs.
And his hair is all black and his
Oh yeah, and then
and his bowl is yellow. Usually his hair is all yellow.
Sorry guys, one sec. I'm gonna make sure I get her in. She's stuck for some reason, so. Okay, good.
My friends literally say all the time, I say them all the time.
Come on.
And I fix my
Mhm,
because this program like
Why is that the only one showing up?
Hey, I think you guys want to bet. I can make you
Oh,
wear it
come
out.
on.
I did not. How much you want to bet I can make you wear it out?
Why is it doing that?
$2.
That's stupid.
Zero.
Yeah. I've had ones longer.
Oh, why is this not there?
I had my nails like half an inch.
Jesus.
Why did you cut it?
I don't understand.
My nails, to be honest, but I
Okay, hold on.
man, I wish I did nails. My nails don't grow.
All right, let's try
I
this.
don't even put anything on
I
them.
cut these yesterday.
Everyone's like, oh, my God, you're
I cut these to
I'm like,
here.
no, I just don't want to put
yesterday,
them
and I cut them. Oh my gosh.
I don't know how you find it.
Mine grew too fast.
Mine breaks. Yeah, she could do. I just cut. I don't want any white down.
Okay, let's see if she gets in now. Alrighty, so hopefully that'll work for Sonia because she was stuck. Everybody's carrying on about their fingernails over here. I'm not sure what that's about, but all right. Oh, there she is.
$2.
Or maybe that's Sky. So, so your book did not have a chapter or a section that really covered redox. You girls good? You with me? All right, cool. So I wanted to touch on it for you so you have basic understanding of it because that is what our lab is going to be today.
Did you get your fish yet?
I did actually. Good point, Jules. So let me show this.
There's trees upstairs, right?
Yeah, Drew has one too. Oh wait, I got to switch my camera.
What is it?
So you know how I always name mine fish after scientists, right? So this is, where is he? There he is. That is Bunsen. And he's my new dude. And he's real. This one is like a gazillion times better than
Yeah, it died.
that goofy Herschel. Herschel was just, where'd he go? He's hiding over there somewhere. Herschel was just, Copernicus, who I had before, was super duper smart. And like he would come over when he saw you walk by, he would come up to the glass and he would, woohoo, here I am, feed me. And so he was super cool. And then Herschel, first off, couldn't figure out how to eat because he never learned that when I tapped lightly, I was calling him to the top. Never learned that. And then also when the food landed on the bottom, oh, girls, you with me? When the food landed on the bottom, he would never suck it up. And then he ate his own tail. So Herschel's gone. So we have Bunsen now. And hopefully he seems smarter already. So we are doing.
He ate his own tail?
And that's because that's our lab mostly. So that's why I want to make sure that you guys know what is happening in a redox reaction, at least lightly. You guys are going to have to get too deep into it. So oxidation reduction reactions. And this is a reaction where one thing is going to oxidize and another thing is going to reduce, right? And they always happen together. So instead of saying oxidation reduction reactions, we just call them redox because that's easier to say. So basically what it is it has to do with electron transfers and there's oxygen involved. So in this little graphic here, you can see that in this case, this one's an electron donor and it's giving the electron over here. Giving the electron over here. This is the electron acceptor. And when this happens, it causes, where am I going? You get this redox reaction where you've got oxidation going on and reduction going on. And oxidation is the giving away and reduction is the accepting, which is what's difficult because you tend to think that if you reduce something, you're making it smaller, you're taking away from it. But in this case, it has to do with adding an electron. So if it helps you to think of it this way, so think about a number line. Everybody knows what a number line looks like, right? 0 in the middle, negative numbers to the left. All right. electrons are negatively charged, right? So if you're adding an electron, you're actually making a charge more negative. So if you were to put the charge of that atom, not that atom, sorry, that molecule or compound or whatever on a number line, it would be smaller. So that's where kind of like the reduction idea can come in. So oxidation involves loss of electrons. And in oxidation, the gain of oxygen, the loss of hydrogen, and the loss of electrons. So when it's being oxidized, it's losing electrons and it's gaining an oxygen. So if you're losing electrons, you're becoming more positively charged, right? Because electrons are negative. And reduction involves gaining, but it's gaining a negative charge. So it's the charge number gets smaller. So that's what you have to kind of keep that in your head. Oxidation, reduction. And because it's confusing, there are some really great little mnemonic memory devices that I've got in here that should really help you remember it. I still use them. I mean, years later, I still use them. So the reduction is the loss of oxygen, the gain of hydrogen, and the gain of electrons. They always occur together. So you have oxidation, reduction, or we just call it redox, right? And it's reactions in which one species is reduced and another is oxidized. And thus the oxidation state of the species involved must change. So the oxidation state has to do with the charge of that particular species, okay? And you'll see it today in the lab when we do the calculations towards the end. It'll make a little more sense when you actually see the numbers involved, but all of the species involved will have an oxidation state, which kind of tells what their charge is. And then if they gain electrons, they become more negatively charged. If they lose electrons, they become more positively charged. And this is just a little picture at the bottom. This is from BJU Press. So, but it's got your little electron going from A to B, and now their charges are different is what it's showing you there. So this is the weirdest GIF on the planet. So now a strange cartoon, and this is from the Azerbaijan Chemical Society, but it made me laugh. It's like, now I will displace, see you. Well, see you would be copper, see you. And copper is gonna eat the electrons. And then, oh, boo. There you go. Now you have a Cu ion. And this guy said, this is just weird. I was searching for pictures to put in the slideshow and this popped up. And I'm like, I have to, this is so strange. I have to add it. He just ate. Look at that. He eats them. I'm not sure why. You got zinc. He's displacing copper. Copper's going to munch up these two electrons. And then you got your zinc and your sulfate, and now they're friends. And I don't know what happened here, but it's bizarre. And I guess this makes sense in Azerbaijan.
I don't know if it makes sense.
It just made me laugh, so I had to share it. So here are some ways to remember oxidation reduction. So we have dealing with electrons. So one, probably the oldest one, or one of the ones I've heard for a real long time, is oil rig. Okay, so oil rig is oxidation is loss, reduction is gain. As long as you remember that it's loss of electrons, or gain of electrons, you're good to go. Oxidation is loss, reduction is gain, oil rig. So oil rig is one that's used pretty frequently. You know what oil rigs are? Where do you find them? Anybody know? Yeah, in the water most of the time, right? Like this? Yeah. Mm-hmm.
That reminds me of the, you know, the scene from Cars, where they have that in the.
Oh, they have that in the desert, or is there one with it in the water?
It's in the water.
Oh, is it in Cars 2 or one of them? I don't remember it.
I think, yeah. 'Cause I don't think they're- yeah.
They
Or
first
first
like
one.
use dynamite or something to find pockets of gas, and then they drill down and like extract it or something.
Yeah, I'm not sure how they find the spots they're going to use. I don't know how that technology works. I do know that oil rig workers go for, it's kind of like being in the Navy where you go for a spell and you're gone. So they go, I know, for months at a time, and they live on the oil rig in the ocean, and it is not pleasant, and it is a really hard job. And I think they get paid really well for doing that, for whatever, for being a job that's a skilled job, not you don't have to have a college degree to go work on an oil rig. but it's one of those skilled jobs that it's like a micro dirty jobs type of thing, right? It is dangerous.
If something's dangerous, they're gonna pay you.
It is, and you have to be very careful and very responsible because, sorry, because what happens if, you know, that oil rig springs a leak somewhere?
The fish.
Yeah, it gets into the water, right? And once that oil gets on the surface of the water, it floats.
The company might
It
get
goes
sued
everywhere.
if you're-
Yep.
you're-
Do you remember the BP oil rig? Do you remember that one? That was, bless you, sweetie.
Bless you.
It was probably, oh, I don't know how long ago it was. You guys may be too little, may have been too little to remember it, but there was one in the Gulf.
Yeah.
And it was, yeah, it was
What
BP.
year was it?
It was a good while
When
back.
they light it on fire,
Hey Siri,
there's still pollution.
what year did BP's oil rig Gulf of Mexico? I don't remember if it leaked. It caught fire, I think. Maybe she didn't, but she didn't want to talk to me. Ah, look at this. She just went back to sleep. Like, oh, cute. I'm telling you, virtual assistants are
Don't
sometimes.
they usually light them on fire to get rid of the oil?
They do that, not on purpose. I mean, not that I know of. It was,
Google's your
but
smart.
people were doing. Oh yeah, explosion. It automatically fills. There it was. It was called Deepwater Horizon, and it was in April 20th, 2010. And it, yeah, Deepwater Horizon was what it was
There's still
called.
pollution from it.
It wrecked all of the beaches in the Gulf.
2010?
2010. So you guys were
Yeah, I was born.
very little. Okay, or just born. Yeah, there you go. So yeah, it was oh yeah, there's videos of it. Maybe I'll show you one when we're done with this lesson. But it was a big old deal, and there were
We got saved, right?
killed 11 rig workers. There you go.
We probably got saved, yeah.
Did I just lose her again?
Yeah, I think so.
Where'd she go? My Saint Bernard is 113 pounds and 7 months old. Okay, so she's coming back in again. There she is.
I don't know anything about dogs.
There we are. Hopefully that fixes it, Sonia. Sometimes logging out's the way to go. All right, so another way you can remember them, girls, you with me? Another way
It
you
actually
can
exited
remember
me out.
oxidation reduction is this one. Leo says grr. Okay, Leo says grr. Seems a little weird and maybe infantile, but it's not, because these things actually help you. So Leo says grr is lose electrons oxidation, gain electrons reduction. So this one actually includes the word electrons. So you have Leo says grr. I like Leo. That's a cute Leo. Leo says grr, lose electrons
Pretty
oxidation,
creepy.
gain electrons reduction. Yeah, it's a good way to remember though.
Like some kid like dressing up for like the school play.
Yeah, yeah.
Right? That's the kind of costume they would give.
That would be a great costume. And then another way to remember them is, I love this one. This one's new. I had never heard of this one till this year, so somebody came up with this. Electron loss means oxidation, which obviously means electron gain means reduction. But electron loss means oxidation, spells out Elmo. So I guess somebody got creative and threw in some
Almost
Muppets.
scares me.
I never argue with Muppets. I love
Yeah.
me some Muppets. So.
Elmo is in.
Elmo's a
the
boy?
street.
Yeah.
Almost scares me.
He's not in the Muppets.
Yeah, he's in Sesame Street, but they're still Muppets. Sesame Street's still
Sesame
Muppet.
Street isn't.
He's
my
very
favorite.
cute. Have you
My
ever seen
sisters
the
love
guy?
it, but I
Oh,
don't.
he's a big guy, which is funny because he doesn't look like he would make that little voice. He's a big dude.
I don't like his
Yes,
voice.
It's kind of funny. That little tiny voice comes out of him, and it's like, wait a minute.
Almost
It's not
scares me.
real. It's freaky that there's a giant thing with a
Uh-huh.
tiny voice.
And do the Elmo voice.
Can he really?
And
That's
whenever
funny.
I come in, he's like,
Elmo scares me.
in the Elmo
I feel like he's gonna steal my soul when I sleep.
That is cute. That is cute. Do you guys remember Elmo's fish's name? Come on, y'all are old enough to know Elmo's fish's name.
It's dead.
No, he had a fish. Elmo had a goldfish. Do you remember its name?
Stop running that one.
I have no idea.
Dorothy.
Oh, no, big word.
So my comment on the Elmo,
And
my comment on the Elmo is, if you didn't read that in his name, there's something wrong with you. If you didn't read electron loss means oxidation in his little voice in your head, there's definitely something wrong with you, because you have to do it in your head. You have to hear it. It's like the memes. It's like the memes with Morgan Freeman. It doesn't matter what it says. If you put Morgan Freeman's picture in your head, you're reading it in his voice. You don't know who Morgan Freeman is? Oh,
How do you not know who Morgan Freeman is?
Oh,
So here are our
scares
3
me.
ways that we can remember. So what does oil rig stand for? What's the first word?
Oxidation.
Right?
Oxidation
Is
Is loss. Yep.
is loss.
Yep.
Reduction.
Reduction is gain. Good. And what's the Leo one?
Loss.
Leo.
Lose.
Electron.
You got it. Lose electrons.
Oxidation.
Yes.
Gain electron reduction.
Yes. And then Elmo is
I can't.
electron loss means oxidation. Yeah. So there's lots of ways to remember it. Lots of ways to remember it. And that was helpful. so oxidation and reduction. I have a video. Maybe. Here we go. So this is kind of a short video. It wasn't too long, but it gives a good.
Chemical reactions taking place
Okay, you girls watching?
are some form of oxidation and reduction reactions. So what are oxidation and reduction reactions, and where do we find them? In the 1700s, the word oxidation originally meant a reaction with oxygen, where oxygen was added to a compound. This was because oxygen was the first known oxidizing agent. However, the definition of oxidation has become more general these days, including other types of reactions. In modern chemistry, oxidation means the loss of electrons during a reaction, and it doesn't necessarily involve oxygen. The opposite process of oxidation is called a reduction. The word reduction originally meant removal of oxygen, but in modern chemistry, once again, it means gain of electrons during a reaction. In a chemical reaction, one species loses electrons as the other species gains electrons. Therefore, oxidation and reduction reactions take place both together. That's why oxidation and reduction reactions are simply referred to as redox reactions. Oxidation, reduction, electrons, what? Are you confused? Let's just remember the acronym LEO, the lion, GER. What this stands for is loss of electrons is oxidation, and gain of electrons is reduction. Or you can remember it as oil rig, which stands for oxidation is loss, reduction is gain. That is loss and gain of electrons, of course. Now, where do you find oxidation and reduction reactions in everyday life? Number 5, combustion. Burning wood in the fireplace, burning coal, fireworks, lighting a matchstick. These are typical examples of combustion. Combustion is a redox reaction where a compound being burned is oxidized and oxygen in the air is reduced. The combustion reaction is also used to fuel the space shuttle. The fuel tank of the space shuttle contains super cold liquid hydrogen and the liquid oxygen in separate compartments. When they are mixed and burnt, they form water and release enormous amounts of energy. Talking about space shuttles, do you know what happened to the space shuttle Challenger? It was in January 1986 the space shuttle Challenger broke apart 73 seconds after launch, killing all 7 crew members. Well, what caused this disaster? An investigation concluded that due to an unusually cold weather that morning, a rubber seal in the shuttle's booster brackets became stiff. This allowed superheated gas to escape and burn through the external tank. The external tank collapsed, spilling liquid hydrogen and oxygen inside. As you can imagine, mixing liquid hydrogen and oxygen created a huge fireball. This was a combustion reaction horribly.
What?
Number 4.
There it goes. That was weird.
Another classical example of oxidation is corrosion. Corrosion is a process where metals are eaten up gradually by the oxygen in the air. In a way, corrosion is a very slow combustion. Most metals react with oxygen to form oxides. The oxide of iron is commonly known as rust. In this reaction, oxygen gets reduced while iron gets oxidized. Number 3, photosynthesis. Photosynthesis is the most common everyday chemical reaction. It takes place in the green leaves of the plants to convert water and carbon dioxide into glucose and oxygen. The plants use glucose as fuel or food. We breathe oxygen that the plants release into the air, and in this reaction, water is oxidized and carbon dioxide is reduced. Number 2, battery. From flashlights to mobile phones, batteries are indispensable in everyday life. Batteries have 2 electrodes, and an electrolyte in between them. Alkaline batteries such as Duracell uses zinc as the anode and manganese dioxide as the cathode. When you switch your flashlight on, zinc gives up 2 of its electrons, leaving zinc ions behind at the anode. It is an oxidation reaction. The electrons pass through the flashlight, turning the lights on. Then they re-enter the battery at the cathode. These electrons combine with manganese dioxide to form manganese oxide. It is a reduction reaction. To carry back electrons from the cathode to the anode inside the battery, charged ions flow through an electrolyte solution between the electrodes. This completes the circuit and powers your flashlight. Number 1, digestion. Digestion? Who would have thought? Well, food molecules such as glucose, for example, react with oxygen in the body and break down into carbon dioxide and
Hello. Weird. Why are you doing that? There.
energy is released in this process, which keeps us alive and grow. This oxygen-glucose reaction is slow at ambient temperatures outside the living cell, but happens fast in the body with the help of enzymes. Well, that's it for today. If you learned something new today, give this video a like and share it with your friends.
Yeah, like, share. Blah, blah, blah. So those are good, common, everyday reactions. Now, next week, I think it is, you're really going to be focusing on some batteries, different kinds of batteries and how they work. And the lab is going to be super duper, 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 duper fun. Super duper fun. And Senya and Jocelyn have it in their lab kit. Did you guys see what next week's lab is? Did either of you look at it?
No, I just took my sheets out of it when I was.
Yeah, I can't hear her very well either. Yeah, it's weird. Yeah, it's going to be electrolysis of water. So basically, we're going to take water and use electricity to separate it into hydrogen and oxygen. It's really fun. I love that lab. All right, so oxidation number. So this is what I was talking about how there are charges, right? So the oxidation number, they also call it the oxidation state, is the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. So electrons, remember, those are negative. So this is how you assign an oxidation number when you're working through an oxidation reduction problem. And this is the sort of thing that, like, if you're in college chemistry, they'd want you to memorize all of this and know it for a test. No. No, it's not, especially when it's what you're doing, like it's your thing. Yeah. Yeah. Yeah, I don't see, I mean, certain things you should absolutely memorize because they should be like this. But there are other things where it's more important for you to know the concept and know how to access the data, especially now since all data is like, it's ubiquitous, right? It's in your pocket. You don't need to know the capital of Poland if you can. Yes.
I figured out a way, like, if you ever need to memorize periodic table,
Oh, yeah.
you buy a shirt that has periodic table on it and then just look at the shirt.
And just look down, upside down. You'll be good at memorizing upside down.
I already know.
There you go. So basically, you start, it says here, with any element that's uncombined. If it's by itself, it's going to be 0. And then it gets into stuff like oxidation number of a monoatomic ion, which would mean it's made with one atom. That's going to be -1, for example. There's that chloride there. And then it starts about more electronegative elements in a binary compound as assigned. Was this chart in your notes? I can't remember. I don't know if this chart was in your notes or not. But there are all these rules for how you go about assigning things. For example, when you get down to here, the sum of the oxidation numbers of all atoms in neutral compounds are going to be 0. So if it's neutral, if it's not an ion, if it doesn't have a charge, then your oxidation number is 0. But you guys don't need to memorize it. I just want you to know that it's a thing, that oxidation numbers are important because we're going to need them in today's lab. You're going to use them. So, oh, that's the same thing. Okay, here we go. So here's another way to do it. You can look at the periodic table and you can get oxidation numbers based upon how it's arranged. Now, remember when we talked about how the periodic table is arranged and it involves the number of valence electrons? Do you remember valence electrons? I hope you guys do, because that's a big important thing to remember. So your valence electrons are the ones in the outside shell, right? So if you look here, these guys are a +1, and a +2. So if it's a +1, it means it can take 1 electron, right? To be neutral again. Because if your charge is positive, you're going to need electrons to make you negative. Does that make sense? Because electrons are negative. And then over here, you've got 0. Do you remember what these were called? These elements that exist right here in this column? Yes, noble gases. And why were they stable?
Because they have too many friends on their friends list or something.
Yeah,
They didn't have space.
Yeah, they're stable because they're all hanging out in this group together, and they have their outer shell is perfectly full, right? Their valence.
If you play
Yeah.
this game, you probably have a friends list. Like, I don't know, you guys probably played Roblox. So maybe you maxed it out or something.
Yeah, basically their valence shell is full, so they don't have anything to give away or anything they need to take to be full. They are satisfied with life. You know, they're like you said, their friends list is complete. So they are just hanging out over here. So this chart right here is super useful if you're trying to determine oxidation numbers. So half reactions. I want to tell you all about half reactions a little bit because we're going to do a half reaction today in lab. So a half reaction is either the oxidation component or the reduction component of a reaction. And we will have to use a half reaction in today's lab. So this is what they look like. This one's much shorter than the other one. Cool sound effect.
In this video, we will learn how to write half equations for simple redox reactions. A half equation shows what happens at one of the electrodes during electrolysis. So we do need to be able to complete and balance half equations for these reactions. Remember that oxidation occurs at the anode and reduction occurs at the cathode.
She like
Let's have a look at a simple
I don't know.
redox reaction. A strip of copper wire is placed in silver nitrate solution. Over time, the solution changes color from colorless to bright blue. You will also observe silver metal crystal deposits on what was once copper wire. Why is the solution turned blue? Pause and think. This is a single displacement reaction. Copper metal, which is higher on the reactivity series, has displaced silver in silver nitrate.
We did that
The
at
solution
the beginning of the year, you remember?
Because of the copper 2 ions in the solution. This is also a redox reaction where a reduction and an oxidation are occurring simultaneously. Hence the term redox. Remember that oxidation means the loss of electron and reduction means the gain of electrons. So for a redox reaction, electron transfer has to happen with one substance losing electron and another substance gaining electron. The silver nitrate is an ionic solution containing Ag positive and NO3 negative ions. So there's the equation again.
So here's how the half reaction works, okay?
Separated. The copper metal has been oxidized because it has lost 2 electrons to form Cu2 positive ions.
So you see that right there? It's been oxidized because it is now positive on the other side. So oxidation is loss, right, of electrons. So if it goes from neutral to positive, it's lost electrons because they're negative, right? Okay.
We now have a half equation, whereas the silver ions have gained electrons to become reduced.
See that? He was positive, now he's negative, so he's gained an electron, so he's been reduced.
You got it
And
at
by this half
Yeah.
equation.
college school.
They are called half equations because each equation represents half a redox reaction, either the reduction reaction or the oxidation reaction. When the two equations are added together to form the final redox reaction, you can see that everything, including the number of electrons, are balanced. To reform the ionic equation, the electrons are equal on each side and can be removed. What about those nitron ions in the original equation? As the nitron ions appear on both sides of the equation, they're called spectator ions.
Do you remember
And
those?
they have no effect on the
Spectator
overall
ions?
action.
What's a spectator do?
Like spectators in a football match have no
Spectator watches, right? Doesn't participate in the game.
Doesn't affect or interact with,
Right, they're just there.
kind of like
Yep.
gain.
A ref.
Yeah, like watching but not getting involved.
Redox reaction. In the
Like an audience member.
chloride oxidizes iodide ions to
It sounds like she's
iodine
like touching her
solids.
mind.
So what happened to the iron here? He had 3 positive charges. Now he has 2. So was he oxidized or was he reduced? Yeah, there you go. Because he was reduced because sorry, 3 positive. Now he has less positive. So if he had to, in order to get more positive, he had to gain electrons. So yeah, oxidized it. Reduction is gain. See, I'm doing it. I have to do it every time in my head. So he was reduced.
Write the 2 mark equations. Pause the video and work out the options.
So there is, right here is a little graphic to remind you that you got your gain of electrons, your oxidation number decreases. Your loss of electrons, your oxidation number increases. So if you want to identify your redox agents and reactions, your oxidizing agent is the one that adds oxygen usually. Not always, usually I'm going to add oxygen to the other substance or remove hydrogen. So if it's not oxygen that it's adding, it's removing hydrogen. And then your reducing agent is going to remove your oxygen usually, or it's going to add hydrogen. And I like this one. What did the oxidizing agent say to the reducing agent? Your loss. Oxidation is loss. This science cat is in a million like science dad joke memes. He's everywhere. I don't know, but he just is. So your homework question, which was for turn in, but I'm curious to see what you guys remembered. Did anybody come up with anything? It's research your redox reactions in everyday life, describe one example and list its chemical equation. Did anybody find that? Label the oxidizing and reducing agents. I'm just curious to see if you guys can get some. So some examples that you might have come up with might have been,
Turn it in, right?
yes, might have been combustion. Did anybody find a combustion reaction? You did? Ella, what did you find specifically? Do you know? Do you look at she doesn't know? You're fine. You don't have to share it if you don't want to. And how about corrosion? Did anybody find a corrosion?
Wait, what was it?
There's corrosion right there.
I took mine in already.
Yeah. Do you remember what it was?
It was combustion.
It was combustion. Okay. So it may have been a combustion reaction. It may have been a corrosion reaction. It might have been an oxidation reaction. When a chemical substance takes on the oxygen, there's some oxidations that aren't necessarily obviously going to be like combustion or corrosion. How about when you slice an apple and you leave it on the table? Yeah, that's oxidizing too. Yes.
Everyday redox reactions include, I can't pronounce it.
What? Do your best. What is it? Photosynthesis.
Photosynthesis.
Yeah, that's a big one.
That's the one I
respiration,
did.
Yes.
combustion, corrosion.
Corrosion. There you go.
Biological process, rusting, and batteries.
There you go. Very, very good.
We only need one.
Oh.
So that's all right.
I have a suggestion. If you're gonna search something up, just pick the one easiest one you see, so that you know how to say it, and it's easier for us to.
That way it's easier for you. It's less work. But I like that you did all of them. That was good because that means, no, I like it. That means you looked them all up, which is really good.
It's just a suggestion.
He's giving you a tip to make your life easier. But I like what you did. So yeah. And like she said, photosynthesis, respiration. And you guys remember photosynthesis and respiration are opposite reactions, right? Always gonna be opposite reactions. So you have an oxidizing agent. Remember, that's the one that gives up oxygen or takes on electrons. And then you have your reducing agent, which is the opposite, takes on oxygen or gives up electrons. And so what happens in reduction with electrons? Yes, reduction, they gain electrons. So if it gains electrons, what happens to the charge? Does it become more positive or more negative? You got it. Yes, Ella, good, Ella. Yay! All right, if you're up. Reducing, reduction is gain. Gaining what? Electrons. What's the charge of electrons? Negative. So the overall charge becomes more negative. So wait, let's try something old school. All right, so everybody, I'm gonna ask the question and you all are all gonna answer it at once. This is old school, but this works. So reduction is what? Gain. Oh, try that better. Reduction is gain, right? Gaining what? So it makes the charge more. Good, Ella's got the idea. Let's try the other one. Oxidation is loss. Loss of what? Which makes the charge more? Yay! That's it. Okay, that's the idea. If you can run that through your head,
I don't think more positive is actually.
more, it is actually, it is a thing, more positive. You can be more positive or more negative. It's a chemistry thing. Weird, but it's a thing. So, Senya and Jocelyn, today's lab I filmed for you all. Now, because I was dealing with a limited amount of my iron 2 sulfate, yours is, the one I ran through lab is more dilute. I know the molarity, but it's more dilute than the one they're running today. So you guys are going to get different numbers than the ones that Senya and Jocelyn and anybody else who's absent, Sky, whatever, are working
Are
through.
we on lesson 28?
So no, 27. So the lab today is going to involve, and I'll tell you girls too in case you haven't looked at it yet, but the lab today is going to involve potassium permanganate, which is one of my favorite solutions just for its color. It's beautiful. Potassium permanganate and then iron 2 sulfate. And because you aren't here, I'll let you know this, but iron 2 sulfate smells like rust. If you've ever smelled rust or smelled like, you know, keys smell like?
Ew.
Okay, that's what it smells like. So if you get it on you and you're not wearing gloves or something, you're going to smell like rust. It's not going to kill you, rinse it off, but you're going to smell like rust. I know. It'll also get under your nails and change the color of them. So, huh?
Does it smell like proper beans and like?
No, it smells like an old rusty tractor left in a farmer's field for years and you get it on your feet or whatever. That slight smell of Georgia dirt. Because that's iron oxide that's in our dirt, right? That's rust, basically. Oh, yeah. Ooh, that is a brownie point. Ooh, you guys are so close.
Are we getting
I don't know, but you guys are super close. I think I still have it open, do
They're
I?
only in emails, right?
No, they're anywhere you find them.
So on one of them, I saw it said do
Ooh, you're at 21, y'all.
third something.
We have to find it to show it to me. She found it.
I can't find it.
So yeah, I was obviously borrowing it from another date, copied and pasted from another date. Yeah, I did see it was in the it's in the syllabus that way too. But yeah, so obviously that's not correct. You have to get 25. You guys are on 21. You're so
It's on
close.
lesson 26. Do 3/16 in class.
Do the cyber
That
rats
was
get
last
brownies too?
No, that was this week. So lesson 26, the lab from lesson 26. Did it say the lab? Yeah, that's right.
Complete lab do 3/16.
Yeah, that's right. But remember, we ended up switching last week's lab last minute, and I said, nah, we're changing the whole lab.
All right.
You were close though. All right, so when you girls watch the lab, it's in the, if you go to Teacher Ease, the assignment and the instructions are in there. But I tried to do it on a white background so that you could see the color change better. And I ended up like fighting with my hands the whole time. So it wasn't the best I've ever done. I was trying to get a good camera shot. This is the redox titration lab. 27, whatever today is. 27. 27. Yes, Trinity
Today's
homework.
the
All right,
16th.
I'm going to let these girls go. Do you have any questions? You girls good?
I'm good.
All right, I'm going to let these girls go so we can get going on our lab. Bye, girls.
Bye.
See you later.
Lesson 26, and you turn that one. I'm sorry.
Yeah.
Bye.
Bye.
Yeah, we will. And boom, let that go. Oops, no, I'm not doing this. You turn in the homework for this week. Yes, whatever that was. 26, 20. What is today? No, is it? We're on lesson 26. Yeah, 27. We're on 27.
But it says 27.
Oh, you're right. That is a typo. Alex just found another.
This is.
Woohoo!
It says 26 at the top, but
Yep.
at the bottom
It says 27. So it is 27, but you guys are now at 22 of your 25 brownie points.
I'm so hungry for brownies right now.
I hate brownies.
I can take my own brownies at my